Right, now looking at question 6 on this exam, we have 3 pairs of carbonyls and we're trying to identify the more reactive one. So for part A, we have 2 cyclic carbonyls. One is part of a 3-membered ring, one is part of a 6-membered ring. And the 3-membered ring is going to be more reactive. Why is that? Well, we know that 3-membered rings already suffer from a lot of ring strain because they're being forced to 60-degree bond angles. But when you stick that carbonyl in a 3-membered ring, now instead of being 120 degrees, it's been forced down to 60 degrees. And so if you're able to add a nucleophile to that and at least make it sp3, now you have something that only wants to be 109.5 being forced to 60 degrees. So still a lot of ring strain, but you're actually releasing quite a bit of it by going from sp2 to sp3. The 6-membered ring, you may relieve a little bit of ring strain, but nothing all that significant, especially when compared to the cyclopropane ring. So the 3-membered ring with the carbonyl is going to be quite a bit more reactive than the 6-membered ring. In part B, the big difference is we have a TMS group. TMS, recall, is a silicon with 3 methyl groups. This is an electron donating group. Well, electron donating groups in general make carbonyls less reactive, and this case is no exception, so acetone, the molecule on the left, will be more reactive. And our final part, part C here, we have a ketone versus an aldehyde, and we know that in general aldehydes are more reactive, and that's due both to sterics, that we only have 1 carbon group compared to 2, but it's also true because we only have 1 electron donating group in terms of carbons compared to 2. So all other things being equal, the aldehyde will in general be more reactive than the ketone.